Okay, dog, I'll let you in. Come on. You don't want to come into my room? Sure. Okay, why are you whining then, my dog? Let's just see if my stream is going. Got an ad on my Twitch for Alienware with Windows 10. That is great. I love Alienware. This stream is brought to you by Alienware. Actually, it's not. Okay, let's put some music on and get started. This is just the fish who saved the planet. They're above the Treeline album. It's pretty good. I don't know what that is. Okay, so what do we do in this stream? Get Vim bigger. Alright, so today's stream is probably going to be maybe an hour long, and we're going to do DOSBox networking on it. And we're probably going to be debugging DOSBox for reasons I'll mention a bit later. Okay, so here we have our DOSBox, but we need to get it to access the internet, or at least Twitch's chat. How do we do that? Well, most computers connect to the internet using Ethernet these days. Oops, let's just open up Wikipedia. So Ethernet is just that cable, and usually you run IP over it. So that's the internet protocol. I don't know why they have to put protocol at the end of all the abbreviations. It is weird. I mean, look at this. Why is there so many P's here? I mean, I don't know. So this is going to be a very P day. So usually you have IP over the Ethernet, and that would be the link layer here. And that's how you link computers together. But if you actually live in a house like I do, you don't have an Ethernet to the internet. You have like a phone line that it connects over. So you hit the same problem that you do with DOSBox, where you don't have an Ethernet connection, but you still want to access the internet. So in my case, I have one of these. They call it a modem. Well, not that, but it's like broadband. Except we don't have broadband, but it's a DSL modem. It's the same thing. So let's look up what DSL is. Please, Wikipedia, I need you. Yeah, so it looks like this. So you have your router, and that connects to the laptop in your LAN by Ethernet, and then it connects to modem to a DSLAM, and that just sends you off to the internet. And that is done not using Ethernet, but you still got to send IP packets over it, right? So how does that work? Well, use the PPP, which is point-to-point protocol. And so this is basically a tunnel. You can set two ends to use PPP, and you send IP packets over it. There is no good diagrams on Wikipedia today. Yeah, so let's just quickly search up PPP dial-up. And this, I'll tell you in a second while I'm searching this up, but let's just try and find an image. This is not helpful at all. Am I going to have to draw an image? Do I have something installed that can do that? can spell. My Google foo is not good today. So, let's open up GIMP. I don't have GIMP installed. Let's open up Vim and we'll do some ASCII art. So, usually you have Ethernet, then on top of that IP. And that's how your house works. So you have Ethernet, and that's generally how you connect two computers together. And then maybe you'd have a router in the middle that just sends Ethernet. And then on top of that, you'd have computer A talking to computer B there, and they send IP packets, but that's tunneled over Ethernet. And so if you want to access the actual internet, you're going to have to connect your Ethernet to your ISP's network. So you'd have your router, you'd have your ISP's network, and this isn't how it's done. What you actually have is phone line and a modem. Wait, no. Modem, phone line. And then you'd have PPP to tunnel it. So PPP or Ethernet let you tunnel IP packets. And PPP can run over your phone line. It can also run over Ethernet, and that's generally what routers use today. So I'll just give a quick diagram of that. There is no actual good diagrams here. Google search, you have failed me. Maybe I need to log in so I can send more tracking stuff. Okay, so let's get to DOSBox. DOSBox doesn't have any networking interfaces, so we can't use Ethernet. What does DOSBox have? It has serial ports. So if I do something like echo 1 to COM1, it will send 1 to the serial port. And so we need to connect something to the serial port, and what we would do, like in dial-up days, is connect PPP to it. Then DOSBox would get internet packets over the serial port because they'd be encapsulated in PPP. And then all the applications could use that. So I'll actually try and find a very good diagram here. PPP over serial. This is basically the same as, oh my god, my microphone. Basically the same as dial-up. So I'll see if I can find a dial-up diagram. There's nothing here. I don't know what I'm expecting, but my expectations have fallen. So, do another diagram. So let's just pretend that this computer here that I'm actually on is going to run the PPP server. So I can pretend to be my own ISP. And I will have IP, and I will have PPP, and I will have serial, and then we'll have DOSBox. And that will have IP, and that will be sent over PPP, and that will be sent over serial like that. So this is the alternate setup to just having it over Ethernet, where serial here would be Ethernet. So we have this layer of indirection serial here. So how do we actually send stuff over serial? Because we don't actually have a serial port, right? Let's go to Wikipedia and search up serial port. This is what a serial port looks like. Let's look at a pinout. I'll actually go to the nullmodem page because that does have a pinout for serial ports. So a serial port basically looks like this. You have your ground, and you have a receive line and a transfer line, and you send your data there, and it goes to the other end of the serial port. So in my case, I want this end to be the PPP end, and that end to be the receiver PPP end in DOSBox. But we don't actually have these physical lines to connect. So how do we actually connect it in DOSBox? We have a few options here. We have, from what I've looked at, we have direct serial, which allows us to connect it to a Linux or Windows serial port, so an actual serial device. Or we have nullmodem, which allows us to connect the serial port to a TCP port. And the first problem with nullmodem that you might see is that if we're doing it over TCP, it's just going to have the data that's in the serial port, those lines. The RX and TX here. But what are all these other ones for, right? Wow, I'm sounding like John Blow, I need to cut that out. There are other pins on the serial port that might be used. And with a null modem, you're not actually sending those, because how would you even send those? You'd need two connections, and that's not what DOSBox is doing. So we're going to have to open DOSBox's source code to see what's up. So let's actually find DOSBox and download its code and start spelunking. Where are you? So I think this is the version that my operating system is using. Why do they have those delays? I don't know, probably so people can stop the page. This music's pretty good. Let's go to downloads, open the source code, and go to the serial port section and try and get our head around it. So we'll start with just nullmodem. This is a lot of weird stuff, but I've spent too long reading this, and so the main important part that I want to point out, there's two things here. The first thing is that you have this additional handshake control stuff and interpret telnet commands. So the null modem will mangle your input a little bit if you don't tell it not to. It also at the start sets up some of the pins to report to DOSBox. Sets up CTS, DSR, RI, CD, and those are just pins on it. So to DOS, it does look like those cables are actually connected. However, if we go down here, when it's actually time to update those registers, those little cables, as if you'd have it connected to another machine that would be changing them, it doesn't do anything. So it actually will just be equivalent to not this, but to this. So it's going to ignore all those other ports. So I'm not sure how the drivers in FreeDOS are going to go. If they need these pins, this is going to be an issue because the nullmodem does not communicate those. It only communicates these. But we do have an actual direct serial thing called direct serial, which uses the operating system serial ports. And you can see here, whenever it's time to update something, it will actually set the registers to the correct values. Like it will set the baud rate, it will set everything. So this will actually work and preserve the information here. And that's really good. That's what we want. However, I don't have an actual serial port plugged into my computer. So what we would be using is a PTY, which is a virtual serial port in Linux. Google, you have failed me one too many times. So a PTY is a virtual TTY in Linux, and you're probably thinking, how does this even relate at all to a serial port? And it's weird. Linux is weird, and I don't understand it. I'm never going to understand it, but we can at least try. So let's create a virtual serial port in Linux, because if we type TTY, we have a PTS here. So let's use SOCAT to create a virtual serial port. And we'll just connect two together. Is that going to work? No, I need something else. Generates a pseudo terminal. PTY. Oh, no, it does actually work, I just forgot that. So that creates two ends to this serial cable, and one end we could feed into DOSBox, and the other end we could feed into PPP. So this would actually create a virtual serial cable here, which is what we want. However, it's a PTY. So we don't actually know what it does. Like, the main problem is it could be doing this, or if I can actually open up this image, it could be doing this. And now we've looked at the code here. So DOSBox is sending the information to Linux in order to get Linux to send this data. So DOSBox is setting its pins on this end. However, we don't know what exactly Linux is doing with the other end. So let's quickly open the Linux source code. Head over to the kernel. Check out the Git page. Go to the tree. And we're going to head on over to drivers, TTY, pty.c. And then we're going to look for anything to do with those registers. Anything? Is there anything here? Nothing? So this is a bit of a complex situation. TTYs are not serial cables, but Linux uses them a bit as if they're serial cables. So what is a TTY? A TTY can be thought of as a terminal. Like this actual terminal here is a virtual TTY. So there was a great diagram, and I'm going to go ahead onto Google Images again and hope that if there's one thing it'll find for me, it'll be this. TTY subsystem of Linux. That might be it. Yes, this is it. Here we go. So the TTY subsystem is like 3 different things. You have the hardware serial port, you have the low-level driver that actually sets the pins here, and then on top of it you have like line discipline, which allows you to do stuff like backspace and send things to programs. So you're getting a bit away from the serial port. This is the thing that actually writes to the driver. And this is the TTY layer, and this includes things like job control. So if we're operating in user space, and this is what DOSBox is using, the write and read here, it's going through these 2 things and not connecting straight to the driver. And this is a bit of a headache because these could be mangling the input and output or just ignoring the registers. So let's have a look if that's the case. So ideally what we want is DOSBox to be able to set its registers and send things straight to the low-level driver. And that would be a PTY or something. Except the PTY is somewhere up here, so it's just pretending that it's a low-level driver, so it might actually be ignoring things. So the only way to figure this out is to actually look at how it works from DOSBox's side. So let's head over to libserial, have a quick look, skip past the Windows stuff because we're not on Windows. Is that music done? I don't want that to be done. It's good music. Nice. Let's head on over to Fish Who Saved the Planet. This is all CC by music, and this is by Fish. Okay, my dude. You got it, friend. Can I start from 1? That'd be good. So let's see what DOSBox is actually doing to send its serials, its virtual serial port, to Linux. So you can see we have some I/O controls. So let's actually just start writing some notes here. We're going to be using TICMget, serial, GCMCDS, DSR, RI, CD. So those are the actual serial cable ports, pins that sets the registers. And as you can see here, it's actually sending those to Linux. And ideally, those will get passed down to the low-level driver, and all will be fine. But we don't know if that's the case with PTYs, so let's just confirm that. When it sends the character, it just writes to it like a file. That's good. And then we have this really strange function here. And part of the reason I wanted to do this stream is because I have no idea what's going on here. It reads from the serial port, but then it checks if there's a FF byte, like a byte that's all ones. And then it reads again, and then if it's an error, it reads again. So it looks like DOSBox might actually be mangling input that it gets from the serial port. So that's something we're going to have to check if we're going to use the PTY thing. It might actually be, because like the only reason we want to use the PTY is because it preserves the registers above. Nullmodem doesn't, it just ignores it. So we're still going on the assumption here that we can communicate all these between the PPP program in case it uses those. And not just this. But we don't know that's the case yet. So we're still just going to be just making sure it's the case before we go forward. So what else? It sets the baud rate. It uses term info flags. So what are term info flags? Term IOs. It's also important that we check this out, because even though we can use a null modem in DOSBox, we can't use one with the PPP program. It also uses PTYs. So in order to make sure there isn't some kind of weird breakage because we're using a virtual serial port, we're going to have to definitely make sure that this isn't getting mangled. So we'll have to look at whatever term IOs are as well, in order to make sure that our input isn't getting mangled at all. And there's also serial breaks. I think that's just time-based, so that should be fine. And then we have some other things where it sets the DTR and RTS and breaks. So let's just grab those. Okay, so these are the things we want to make sure get to the PPP program and goes to the serial port. And in our case, our virtual serial port is a PTY. So we want to make sure that all of these are supported by the PTY. If they're not, then we might actually end up with a situation not like this, but like this. And that's could be fine, might not. I don't know. I'll also quickly write down this. Let's head back to the close that. Another thing we want to make sure is that SOCAT isn't mangling data. This music is awesome. It's by Fisher Save the Planet, Here's the URL, CC by, it's good stuff. So we're actually going to have to look a little bit further into the TTY stuff, because if we search here, we don't actually have any of the interface that Linux uses with the program. So we're going to actually open up the main page. So the IOCTLs are what Linux actually uses to communicate with user space in order to set these registers. And as you can see, terminals and serial lines are just bunched together, and they have a whole bunch of stuff. Like you have terminal attributes, which are the term IOs. You have the window size. You can send a break. That's important. Software flow control. Faking input. That's a pretty good way to mess up people's systems. Like if you ever wanted to mess with someone's computer, just write a program that like adds, I don't know, RM, RF, everything into the input queue. Controlling the terminal. Process group and session stuff. Like we're not going to be using that, but that's something to keep in mind. Pseudo terminals. Packet mode. What is packet mode? That seems important. Is our serial port in packet mode? Does that do anything to it? Modem control, this is what we're interested in. As you can see here, we have the modem bits, and it has all these things like DSR, DDR, RTS, CTS, DCD. This one's important because this is used often to indicate that there is data ready to be read. And if we don't have that, then some programmers might think, oh, there's nothing ready to read. And as you can see, we can wait for those. So is the PPP program doing that? Maybe, we don't know yet. So we're going to focus on modem control. And let's go check the kernel source again. TTY IO. What else would be here? I think that's, oh no, IO-control. Let's see if we can find anything related to DTR, BCD, RTS, modem. Okay, so it doesn't seem that the actual TTY part is handling these IO controls. Is it in IO here? Okay, so it's in this file that Linux will actually pass on. Not really messing with kernel's deadline. I'm just trying to find out how to send stuff over serial from DOSBox without losing data. Because DOSBox doesn't have an Ethernet port, so we're going to be sending it over serial port, and the only way to do that in Linux is to either use a nullmodem, which uses TCP, or a PTY, and my major concern here is that if we use the nullmodem, it's going to do this, and the program on the other end is going to just wait on these pins that aren't virtually connected. And it looks like a PTY will actually be sending these as well, but I'm not sure yet. So I'm just trying to figure out what handles it. Because when I looked at the PTY file here, we don't actually have any modem stuff. It's very important to look this up so you don't get hit by stupid bugs later. So what do we do here? So cmget obtain the modem status bits, and so when Linux hits that, it looks in the ops for this. So it's provided by the ops part of Linux. Ops, break control. Does this have break control? Let's look for the ops here. It should have ops somewhere. This is the wrong file. Okay, so here's what the PTY things can do. And we don't actually see anything related to breaks or modem stuff, which is a bit worrying. I'm not gonna lie. It's giving me the impression that PTYs are just ignoring all this and having the same effect as a null modem cable. And that's not so good. Let's just check the ops again. PTY ops. Okay. I spent a few hours reading the source code yesterday, so as a spoiler alert, the PTY subsystem does not do this, it just does this. So it doesn't actually send any of the modem registers. It is equivalent to a null modem cable, which makes all this not useful. So we just either have the option of using the PTY or null modems. However, we also have these weird issues because, as I showed earlier, we have this TTY layer and line discipline in front. So is DOSBox writing and going to get stuff mangled here? Maybe. If you've ever used it. If you ever mess with your STTY stuff in Linux, you'd see that it has all these weird things, right? These settings. So you can set your characters, like you can set your EOF characters to just be like D, and then when you type something in, type D in a program, it leaves it. So what if DOSBox just sends one of these characters in its serial port? Is that going to mess with Linux? Probably, but there is a way around that. You set it to raw, and then whenever you send the characters, it's not going to do anything except for what bash thinks it should do. See, I'm hitting Control C, I'm hitting all the special ASCII things that should usually be doing something, and it's not doing, it's passing my ID straight through. So we have the raw mode there, and that's what DOSBox will want, and probably the PPP program. So what else was I worried about with this? Packet mode. What is packet mode? What is a packet mode? Do we want packet mode? Is that useful for us? Is that going to mangle anything? It doesn't seem to be documented much in Google, so let's just search up packet. Sudo terminal, ISDTLs, packet mode. In packet mode, each subsequent read will return a packet that either contains a single non-zero control byte or has the single byte containing 0 followed by data written on the slave side. What? So this seems like something that's definitely going to mangle our input. Can be applied to the master side. In packet mode, each read will return a packet that either contains a single non-zero control byte. Non-zero control byte. What does that mean? Does that just mean like any byte that isn't 0? Oh, so it has a non-zero control byte, and then it has a single byte containing 0 followed by data written on the slave. So in packet mode, instead of just reading data from the other end of the PTY, so if you do read like PTY, instead of getting something like C or a letter, it would either give you, 2 bytes. It would give you either that and C, or it would give you some kind of like control byte. I don't know what the control byte is here. This could explain a weird thing happening with DOSBox, which I'll get back over to here if I can find it. In DOSBox, when it's reading from the PTY, it is reading a byte and then checking if it's all ones. And if it is, then it's reading again, checking if that's 0, and if it is, then it's reading again. And this is really weird, like, because this implies that if it reads an FF, then it's going to skip it. It's going to treat it as a control byte. Which isn't good, because we want to get all our bytes across. What if the PPP program sends FF because it's in some kind of binary packet? DOSBox is going to treat it as an escape. So, is it possible that FF is actually because it's using packet mode and that will never happen? Maybe? But if it was in packet mode, it would read it and then check if it's 0 and then fetch the next value. So this is weird. This piece of code here is weird. I think it's possibly a bug. I'm not too sure. We'll have to have a quick check to see if it is. I did some research on it. It's still present in this form in the newest DOSBox source code and the oldest revision of this patch that I can find. back to 2006. So this code has always unquestionably been here. And from what it looks like to me, it's going to read a value. And then if it's FF, it's going to skip that value. So is it going to eat our... is it going to eat our FF characters? If we look at the Windows nullmodem implementation, it doesn't really do that. It just reads the character. Oh, interestingly enough, it has this code here, where if the character is 0xxx, if it's FF, and it's not transparent, so that probably means opaque, then it's an escape character, which seems to be the same thing. However, this is for telnet. And in the Linux code, if this were telnet, it would be checking that, and then it would do something based on the next value, but it's not. It's just checking if it's an error, so I have no clue what's happening here. It seems like a bug, so we're just going to spend a little bit of time checking out whether or not this is a bug before we go forward and actually use it. So how do we do that? Well, we open up DOSBox, and we have it over here. And then we're going to connect the serial port to something. And to do that, we need a virtual serial port. So let's create a quick loopback one. And we're going to set it to raw mode and not echo anything. This is just what I've seen on the internet, and it seems to be what we need. And on one end, we're going to connect DOSBox to it. So let's do serial 1. Serial, real port, PDS, what was it? 9. And then we're going to connect the 10 part to just my terminal, I guess. Like, we can just listen to what's in it, and let's see if that actually works. I'm not too sure if that's working at all. We don't actually have a terminal emulator, so what can we do? Let's write some code. So we have our COM1. How do we read from COM1? Empty. Let's just say this is a new file. I can't find the save button, so I guess we're just going to override it. So we want to read from COM1 and then print what we've read. So we already have some stuff here. Let's create a quick buffer here. This can be our buffer. And that's, I don't know how long that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll say that's 12 characters, and then I'll just do 3, 4, 5, 6, 7, 8, 9. Just set to 10 characters. So we have a 10 character buffer here. And we're going to read from the COM port into that and then print it. So, first question, how do we read from a COM port in DOS? And to do that, we're going to find DOS interrupts file open or file read. This is just a random page on the internet. But we're going to try and use it. It doesn't have anything particularly related to serial ports here. Buffered input. Is this what we want? No, that doesn't let us set a file. How do we open a file? Okay, let's start there. So the access and sharing mode is going to be AL, and then the file name is going to be in the DX register. And on success, we're going to get a file handler. Okay, so what is that? Interrupt 3DH. Uh, 3DH. I think the interrupt goes to the top, and the lower part is going to be the file access and sharing modes. I don't know what that is. So the first thing we're going to hit here is that there's not much DOS programming stuff on the internet. Which is fine because we have DOSBox. Yeah, we can just open up DOSBox's code and see what it does. If I can find it. Downloads DOSBox. Let's find 3D. 3D. Oh no, that's not correct. What am I doing? Is there anything here to do with files? Yeah, that's the sound that's going on in my head at the moment. Are they just going to use a lowercase d? Where does it handle 21H? 21. DOS files, is that what I want to look at? Source ints. Is this what we want to look at? BIOS int 10. None of these seem like DOS stuff. But these do get called when something happens, so maybe we can follow our way back. BIOS public module base. This looks like a big old interrupt handler. Int 15 handler. Okay, so that's how you install handlers there for interrupts. Set reelback. Okay, so we just need to find something that calls this with 21. Okay. Great. There we go, DOS. No, although this does look actually like the interrupt handler. Okay, in 21 handler. Okay, dog, you can come into my room. Get under my desk. Okay, I know it's like midnight, but I gotta do this. It's for the internet. So, what interrupt are we calling in DOS? 3D. 0 times 3D, 3D. open existing file, and as you can see, this DOS side of the actual interrupt. And it calls DOS open file with the name and the register. So I'm assuming that the mode part would be here. Okay. Flags. Don't allow directories to be open-ended. Okay, I won't. Okay, so this is the actual other side of the interrupt that we'll be calling. So when we call this code here, it's going to then jump to the DOS open file method, and we're going to see how to use that. So it checks if the file name is correct. How does it do that? Because over here it says that it's an ASCII-Z file name. And I believe ASCII-Z is just... yeah, so that's just the name of an assembler. So it's a null terminated byte, I think. So let's just change the call name to that. Sorry. And then we're going to move dx to be the call name. What I'll actually do is I'll set the interrupt here, and then we can set the low value of AL to whatever our bits are. So our flags is 8 bytes, which makes sense. Not 8 bytes, 8 bits. So where's flags used? If flags is greater than 2. What? File open gets the flags. Read-write mode. Okay, so we have open read here. What is that? Surely there's a file that tells us what open read is. No? Open read write? See, this seems like what we want. We want to open it, read write. And there should be some kind of define, maybe? Maybe I need to go back here. Maybe it's somewhere else. Ah, it's in the include. Okay. Open read write is 2. Okay. So that value is going to be 2. Let's see what happens. Because that should give us a valid file handle. So we're going to actually compile that. Why did I do int there? No, this has got to be move. Illegal instruction. I guess I can't use ASCII-Z there. I guess FASM has some different syntax for text. Ah, it's just the DB thing. Okay. Oops. I'll put a 00 after it. And then we'll write open com1. What is with this old Western hello string? Okay, we're just going to comment that out because we're not using it at the moment. And what does that do? Nothing. Now, I don't actually have anything easy for printing to DOS, so at the moment we're just going to hop out of that and we're going to hop in to our debugger. And as you can see here, I believe this is the code that I wrote. Yes, so it moves the contents of the data section 010E. So let's just go to that. And you can see in the bottom right we have COM1. So let's step through that. I think the step button is F4. Nope, that is not the step button. Oh, I didn't break, did I? Okay. Is it D for break? B? F1? What's the button for break? I want to break at the start, please. Break. Alright, this has a menu I can actually use. Okay, set a breakpoint, that's F2. Let's run the program. Okay, so it moves COM1 into DX. F8. Which key is my F8 button? Is it gonna step? It's not doing anything? Let's try resetting the program. Okay, run. Step over. There we go. What is with this cursed clown music? Oh my god. I just don't understand it. Okay, so AX is returning 5, which seems to be good, right? That's the file handle. So if we head back to the DOS interrupt page, CF is clear if it's successful and AX is the file handle. CF is set on error. So we actually need to see what the value of CF is. The carry flag. Nope, okay, so carry flag is right. We've opened the COM port. So let's actually just try and open a different COM port that's disabled. So we're going to do that by editing the program's memory real quick. And we're going to head on over to that. And we're going to just set that to 3. So that's going to try and open COM port 4. Okay, let's head back. Reset the program state. I believe that's actually still kept the value. Nope, it reset it. Okay, so let's quickly set that to 4. And let's run through the program. Okay, so COM4 gives us a carry flag of 1 with an error of 2. So we can confirm that it actually opened it, which is good. It's always good to have stuff opened. How do I exit this hellhole in the debugger? So, we should probably have something that quits. That way we can tell there's an actual error. And now we want to store the file handle somewhere because it's in AX at the moment, which means it's going to get overwritten by whatever other interrupts we run. So what registers do we have in the 386? Where can we put data? Nowhere. Of course, we have no good registers to put data. So we're going to have to probably push it onto the stack. 386 push instruction. The stack is just like memory, but for people who don't have full memory. Memory allocation. Yes, I know how to address memory, or if I don't, I'll figure out who. Okay, push. Okay. So we're gonna, after that happens, we're going to push. Is it setting all of AX or just the low? AX is the file handle. Let's just check with the DOSBox source code. Set file handle. Just set file handle do it. Okay, so it's in that file. No, it doesn't. So it probably does that in the interrupt setup. Well, I've already got that open. Okay. Okay, so it sets it to AX. Alright, so we're going to push all of AX onto the stack. Does that set it to 0? We'll find out in a minute. Let's just open up our debugger again. We're going to break here. We'll break here. And let's run it. Okay, so that updated the stack pointer there. And what did it do? Does AX stay the same? Yes. Okay, so that just pushes it to the stack. Let's quickly have a look at the stack of the memory. Let's set it to SP. And as you can see down in C here, we have 0500, which is AX, but it's split backwards because I don't know why they split it backwards. Someone decided little endian was a good idea, and I don't know, they must have been evil. Little endian is weird. Okay, so we have a file handle now. So we want to be able to read from the file. Oh, here we go. Read from file or device. So is this a blocking read, or is this asynchronous? Number of bytes actually read, so partial read. It has all these things that are unhelpful. Okay, file handle is BX. So we're going to move. Let's head back to our assembler. Let's make this full screen actually. We're going to move BX AX. What are we going to do? Number of bytes to read. Let's read 10. And that's in register CX. And of course, actually let's set that to 8 because I really didn't count those bytes. Is this Pink Floydish music? Whatever. And we're going to set DX to be our hello buff. Then we're going to do int 21h, but we also want to move AX 3F. Okay, that compiles. Let's head on over to our debugger. Let's set a breakpoint there. And does F9 run the program? What's run? Control F9. Okay, so AX, we got our file handle. It's all good. Gonna move that to BX. To CX, we're gonna move the length of our buffer, which is 121. So let's go check that out. And this is our long buffer here. It is actually, yeah, it's 10 long. So I should have put 10, but I put 8. And then we're going to try and read some data from it. And I'm interested as to what will happen here. 8. And it read 1. Why did it read 1? It read 1 and then it read 0D, 0A. So is this because earlier I echoed 1 to it? Let's reset the program and let's just break here and not there, and we can go. Nope, I just killed DOSBox. That's great. I'm a good person. I hit the wrong button. I hit Control F9, which just happens to kill DOSBox. Hey, Speed of Light Pen, what's up? You like DOS? You have a crown next to your name. Did I fork the MS-DOS project? No. I'm just using regular DOSBox. And I'm going to put a Twitch bot in it. But today we're looking at a potential bug in DOSBox because where's the code? It's in libserial, isn't it? Okay, I'll open it read-only. And this doesn't make sense, so I'm just trying to figure out why that's happening. And we're also just trying to read from the serial port today. So I suppose DOSBox over here is the thing that actually... my own implementation of DOSBox or the Twitch bot or... I'm using serial comms. I'm using DOS's implementation to access it. So I'm using all the DOS interrupts. I'm not banging on any registers or memory addresses. So I'm not writing any drivers. Why is my music stopped? Have I run out of music? I'll just put that back on. That was pretty good. So we're connecting DOSBox to a Unix PTY, which is here. Yeah, whacking bit banging is fine. I wish, but you know, DOS gives us some syscalls for it. So why not use the syscalls until you figure out it's absolutely horrible and there's something wrong with them, like this. What is this? Why do you got to be like that, DOSBox? So I'm actually writing some code to see if this is a bug. Because this code says to me that if you put FF into a DOSBox serial port, DOSBox is going to skip it. And that's extremely strange. So, of course, we have to see if that's the case. So we're going to quickly look for our PTY, which I've opened up over here. Dev PTS7. And DOSBox can confirm that opens. So let's see. have I seen this? MS-DOS's IO.asm. Let's have a quick look. I hope this is the same kind of implementation that DOSBox has that MX does, of course. File control block. Where's the serial port drivers here? If serial. Just seems more like the serial IO data port, serial IO status port. So this seems like yeah, so this is the actual DOS code that has the serial port driver. It'd be interesting to see whether DOSBox actually implements enough of the interrupts to run MS-DOS. I'm currently using a bit of FreeDOS in my DOSBox because it has a debugger. But no, I had not seen that. Oh, I'm using the wrong slashes. So let's break at the end of the program. Yeah, I have DOSBox's code here. I keep pressing the wrong button on my keyboard. They run their own I/O, so the serial stuff here actually is in C, and it just connects to Linux's stuff. And that's done using some classes that they call, and they have their own little functions. But anything, I think, past interrupt 21, which is DOS's syscalls, is in C. I think they do fudge some of the memory parts of it, but I'm not too sure. They probably don't. Yeah, it is done in C++, and it is fairly readable. I think the serial port code is almost all in C++, without any faking of registers, so I'm unsure if I could actually bang any of the bits to get my registers. It would be interesting to see one day, but I haven't written drivers that low level before. The most I've written is C drivers. Actually, let's just quickly find out. I wish they'd use Git for I'm getting distracted. I wish they'd use Git for their source code so I can look back in the history without having to download their all SVN stuff. Windows WDF, that's Windows Forms, isn't it? Oh, Windows driver frameworks. Yeah, I've seen bits and pieces from this. It seems like something that you'd want to mess with a bit. But I'm just... Because the NT system, they have like the Win32 API, then they have the whole NT API, which is native code that you put in drivers and system stuff. And that seems interesting to mess with. Something interesting that Windows does that Linux doesn't is provide a stable driver API. The interrupts with C are weird. It's in C, but the interrupts with CPP is weird. Really? I didn't know they'd write it in CPP. I thought NT was written almost exclusively in C++. And I also thought C++ had some pretty good interrupt with C. Are you thinking of COM or something? They wouldn't do COM in the kernel. So here it's looking like it didn't actually read anything from the serial port. So I'm just going to step through that. I'm going to see what's happened here. So it opens it. Does it wait a little bit? DOSBox might actually buffer the data, so let's actually connect something to this serial port. Testing. Wait, how long is that? 7, that's fine. Let's send that into the serial port, and let's see what happens when we reboot the program and step through it. No, it didn't read it. They have, it's written in C, but they have wrappers in C++ for some of the syscalls. So they have a second C++ API on top of it that wraps it. I'm only familiar with Linux's syscall API, and I've been enjoying that because, much like DOS, you just write interrupts to assembly. Yeah, no abstraction there. Because from what I know, in Windows, the driver model is fairly stable, which is what you'd want in an actual good operating system. Not Bash and Linux, but you know, you've got to have those drivers that work across kernel versions. So that didn't actually get any input. Why is that? Was it waiting for input when it froze? That probably wouldn't be the case, because I've looked at how DOSBox works and it regularly fills the buffer. Does it empty the buffer? Does it use a ring buffer? How is it buffering this? Is it buffering it? These are all things that aren't written on the internet. They're in books somewhere, and I don't have any books. So it runs this code to get a character. I tried messing with React OS the other day. It would be very interesting to program for some of that. But unfortunately it just always crashes for me, every single version. And in weird ways. So, you know, yeah, it is bad. I use Linux and I run all kinds of weird stuff, so I'm used to like just my Ethernet port on my computer dying. But none of it crashes in such a way like React OS does. Usually it's kernel faults. Break serial. Do receive. When does it call do receive? It is possible for React OS to be good, but it isn't. I sound really harsh about it. Were they? Were they making it for Rust? Wait, was that to do with React OS or just plain Windows? Okay, just Rust, because I was like for a second, how would you get React OS to even be stable enough to do that? Okay. So it receives a byte, runs do receive byte X, This is strange. Yeah, a .NET emulator in Rust would seem to be a pretty good thing, since I think that wouldn't be too hard to do. You would just have the VM to put in Rust. Okay, so it's in serial port here. This handles the actual serial port. A byte was received. Okay. It has a FIFO. It uses a FIFO, so why you be like that? Why are you not putting the FIFO into my buffer? Why you gotta be like that? Okay, maybe I'm just not putting enough data into the buffer at the right time. So let's do a while true, do done. See, that shouldn't have happened, should it? Because I wrote testing into... Why did I change that to 10? Okay. So now we're bombarding DOSBox's buffer and it's getting overruns. So let's see if that works now. Fill my buffer. Okay. Nothing in the buffer. Why? You have stuff in the buffer. It doesn't look like it set an error code. It does say the error code is the amount of bytes read, and that's 0. Looks like we're going to be looking through DOSBox's source code again. Yay! Where is it? It's not there, it's over here. Read from file or device. So it reads the file, then it writes to DX. Alright, so we're going to cheat a little bit and we're going to use GDB to break here and see what's going on. So that frees DOSBox. Nope. So I have attached to the wrong thing. Did that stop it? Yep. Okay. No. Do I have 2 DOSBoxes running? 21577. No, I didn't compile it with symbols. I didn't compile it at all. So, just makes DOSBox debugging a little bit harder. So I'm actually just going to run it straight under GDB. I think GDB's attaching system is getting a bit broke right now. Okay, so what we're going to do is break on. We're actually just going to run it. And we're going to break when it tries to open a file. Let's continue. And then let's get it to open at the serial port. Which one was it? 7. Okay. So this should be somewhere. No, go away. Okay, so we probably just want to hop on over to there. This is not where I want it to be. Oh no, what? E7. Did I just skip some instructions? Yeah, okay. So what is racks? 0. Okay, I kind of messed that up. But don't worry, we're going to break on read. Let's delete breakpoint number 1. And let's continue. Let's pulse audio. Pulse audio. Pulse audio. Okay, this is more like it. Yes, I think it's trying to read from the serial port right now. Not quite understanding why racks is set to 0. Maybe R11 is where the first argument is to read. arg1 on AMD 64. That should be RDI. So what is RDI? 10. Alright. That was just me being silly. So this is reading from register 10. Not 10. File 10, which should be the serial port. Let's head on over to frame 1. Where are we? What's the program counter? x86 has a program counter, right? I'm getting mind blown. I did this on ARM yesterday, so it was a bit easier. ARM is a lot nicer than it. x86. IP. Is it IP? RIP. Okay. Okay. So this looks like the code that we are seeing in DOSBox where I think there's a bug. So we're there, then it checks to see if it's 1, and then we're going to kind of break here and just snoop on the inputs a little bit. That might be here. Let's just quickly check out what that is. Yeah, okay, so let's put a breakpoint there. Let's delete all our breakpoints first, and let's put a breakpoint there. Or break here. Okay. So it'll now just break whenever I put anything into it. So let's put a single character into it, T, and we've hit a breakpoint. That's good. What registers do we have? It should, is it RDX? Yeah, alright, RDX. So let's just quickly step through it. Let's just continue because that's not FF. Now we're going to print just straight up FF into it. And I'll just quickly do a hex dump here just to show that it's working. There. Indigo. And so what do we have in there? -1, which is FF. And so we should be having, it should compare it and then jump to here. So let's see. Let's also buffer another character. FF. E. Okay, so next instruction, EA. Yep, then it jumps. Oh, I want to disassemble the PC, please. Then it's going to read again. RBP. That's... Alright, I think that's storing something on the stack. I don't know. Then it calls read again. I'm just going to quickly jump to where it returns. Is there a ret here? Stack check foul. Okay, let's just go next instruction. Oops. 10. And at 19, where are we now? It didn't? Okay, that's right. Because RDI isn't 0. I'm getting mind flooded by assembly. F2. That's not the stack I know. Zora 28. Ret Q. Okay, that's good. We actually just want to break at ret Q. If... How does it do its... What's the C colon convention on AMD 64? should be on that. You know what, I'll just check. Let's break here, continue, and see what we're returning. Is it RDI? It should be returning the error pushed by 8 bits and the red value. So there should be T somewhere. Is this it? I would be very surprised if this is it, because that shouldn't be it. I don't want to believe that's it. 10. Hundred, something, 100, something. So that does seem like that's the root value. So we're actually just going to catch that. So we're going to break if RDX isn't 0. Okay, so let's shove something in there. So just normal data E, let's see what it returns. Oh. 65, I think that's E. Yep. Okay, so normally it returns this. So let's continue, and let's shove this into it, xf E. And it still does FF. But then it should get the E again. Yeah. What? Read to character read. Then if it's that, it should read again, right? Shouldn't it? It should read again. Oh, I'm so confused. Oh, whoops. My actual only explanation for this is that this is not reading anything. Why would it not be reading anything? Because it gets the character, it reads this, and it returns that with character read, which is FF, and no error. Is the handle correct? I mean, it is a duplicate of this. So it should be. It's reading something, and then it should be reading the next byte. But instead, it is reading the individual bytes. This cursed Western music isn't helping. Okay. Where did I have my breakpoint before? Let's break back at read. No, not there. Frame 1. Okay, looking through the assembly. Let's try and figure this out. So this is the fast path, I believe. It reads it, it checks if there's a value that it's read in the serial port, so it's polling it. If there's a value, it jumps down to here. That's good. Otherwise, it does something here. I don't know what this does. I think it... That's the wrong window. I think that might just be managing the stack. Yeah, stack pointer. And then it leaves. It adds 10 to the stack pointer and leaves. Okay, so this part, that seems right. I don't know what that's there for. So let's delete our breakpoints. Let's break here. And let's continue. And let's pass in our really weird data. And so what does it do? It compares, well, it sets EBX to 0, compares it with FF, and then if that's correct, then it jumps it to here. Otherwise, it jumps to before there. Oh, that must be the cleanup stack and return, I guess. Okay. So this is the second read here. So let's just continue. Does GDB let me continue? Oh, okay, let's just do next instruction. Yeah, we want to get to 8B. And so I'm expecting it to read the next value. RDI, it read 0. But I put 2 in, right? Why did you read 0? That's the sound of me dying inside. Can I print the stack? Read, and it reads it again, and if it gets a 00, error escape. Okay, is this a libc? Is this a wrapper thing? Is it wrapping something? Because it seems like it's doing something that it shouldn't be doing. Let's just see what glibc is doing. This looks current enough. Read n bytes in the buffer from FB. What are you doing, computer? Okay, let's open up strace. We might actually need to T that. So we're going to open up strace. We're going to connect it to the serial port. And we're going to see what Linux is actually doing. Oh, right, I'm in FreeDOS. Serial 1, direct serial, real port, EDS7. And as you can see, it's just going to constantly read. Okay, and then we're going to quickly print testing x OO EE another test, and then we're going to jump back, and then we're just going to quickly pull this DOSBox and check this file. Testing. What? Is that the buffer? Is it? Oh, this isn't telling me what's being read, is it? Why is it reading XFF twice? Okay, in the context of weird stuff happening, when I send this data, with only one XFFF, and DOSBox reads 2 XFFs, then that would actually make sense. If we go back to the code here, if I can find the code here, that it would read it again and still have FF. So that means our stuff is actually being mangled. So let's see PTY 377 doubling. Okay, there's nothing on the internet. Great. Let's Python something up then. That code does seem correct though. If Linux is going to be strange like that, then that code be, I don't know, working. Do we have Python installed? Let's open, oh, I hit the wrong button. Dev PTS 7. Did I close the sockets? Yes, I did. Dev PTS 7. f.read1. And now it's going to wait for something to read. And let's just print something into it. Let's put that there. No, you're not gonna... Oh no, that's the wrong end. Okay, so you can't decode that. I just want to read 1 byte, thanks. Let's throw up some more music over here. This music is great. CC BY. So this album has actual credits instead of just being written by someone named Fish. Oh, it starts at Treeline. Let's start at Follow the Snow. How do you read a file byte by byte? Does Python not have blocking reads? Okay. Okay, Python, you're flooding my mind and I don't like it. Let's just quickly write some C. It's gonna print 2 bytes and C equals 0.00. I'll just set that to 0. No, we have error no in C. Error no. Alright, so let's do read file descriptor 0, I think. And we're just going to do C, and we're going to do 1 byte, and then we're going to print error no and the C, and do that twice, and then return 0. Why don't I have an error here? And I think we need this for the read. Okay. So the program is going to read dev put 7, and we're going to print something to that. TE. Okay, it gets TE. Test ing G okay, it works there. Let's just make that an infinite loop. And let's print XFF into it. Oh, sorry, that's the wrong end. Yep, that seems to work fine. Okay, DOSBox, you weird, but I love you for it, I guess. That's some deep, dark programming weirdness. I don't like it. It makes me sad, but let's just see how it opens the file. Maybe it opens it a weird way. Open file. Oh, is this... Does this matter? Let's try that again. Let's just do FD. What includes open? Where are you? Sys stat. Okay. Interesting. Okay, so we're only going to print it if error equals 0. So let's try and just... I close my socket. So that should actually open 5. We're nearly at the bottom of the mystery, I can feel it. And let's just echo something. Dev PTS 5. What is happening there? Let's just set C equals 0. If C doesn't equal 0, then we'll print it. How's that going to go? Test. Okay. I should actually be setting ANO to 0 first. Oh, this code's horrible. Okay, so what happens if we pass in this? Oh no, yeah, that makes sense. So if we go 0, 1, nope. So I'm confused. I'm confused. I'm forever confused. Let's just get this networking. Okay, so there's two solutions we can go about this. We can either connect DOSBox to the internet, or just, hello, Lonk52. We can either just connect DOSBox to the internet, or we can connect Twitch to DOSBox. So what's Twitch's IRC port? Using a lot of programs. Do you mean for what particular task? I'm using Linux. That's my operating system. I'm just going to connect Twitch to the serial port because for making the DOSBox, alright, I'm using for the DOSBot, I'm using DOSBox, and I'm going to be using the flat assembler. So let's just quickly do. It looks like this. So this right now should be reading from the serial port, but it's not. So what I'm going to do is modify DOSBox so that we're going to connect serial 3 to the nullmodem, because that Unix stuff is weird and I don't trust it. It's going to be transparent. And server is going to be that port 1235. So DOSBox is going to try to connect to that port. So let's just do a quick test. Netcat listen. And then if we run netstat-l, no, TLUP, I think. Are you not listening, netstat? Okay, netcat 1235. So I can't connect to my local port. Okay, what about 6? You are confusing me. And at this point, I know nothing but pain and misery. Netcat listen. P for port. There we go. Actually, you know what? I'm going to set that to loop back so my house doesn't expose my Twitch bot to my internet. If I can do that. Can I set the source IP? Local source address. I just want to keep that bound on loopback. So let's see what netstat says. Yep. Alright, that's good. So we're going to connect to that test. As you can see, it comes out the other end. What about this thing? Bidirectional. And so we're going to connect DOSBox to that. Can you connect multiple things to it? Netcat. No, so it's only supporting one connection, that's good. One problem is that if it disconnects, it's going to close it. The bot is just going to be a general thing to see how to write one in DOS, more for the novelty of it. So let's see, echo 1, com3. Okay, that is not what I wanted, to be honest. I thought echoing text to my COM port would not send trash data, but we're getting there. It's happening. I can feel it. Ah, that beep. Yeah, I usually program. It's something I do often. What about you? Do you do any programming? We're going to set that to com3, and we're going to try and read from it again. And then we're going to use the debugger. Pygame is pretty sweet. Oh no, what did I do? Did I type something and now it's stuck forever? Oh. I haven't done much messing with Pygame in a while. Insight. I have Insight. How's it confusing? Is there anything in particular that's weird about it? This is some casual music brought to you by this dude who just made cool music. Remake of Asteroids you're working on. Some pretty good stuff. Let's put a breakpoint here and let's just go for it. Run. Ah, yeah, Control F9 kills DOSBox. Yeah, there's a lot of confusing parts of just programming. There's Python, Pygame. By the time you actually have your stuff set up and together, you just basically have to learn everything involved rather than just the language. So as we can see here, it didn't read anything from my buffer. So I'm just probably going to have to write something into it. How about test? And let's try running that again. What? Why? Run. Yeah, so the issue I'm having right now is that no matter if I type stuff here into DOSBox, it's not reading it. Do I have the CD installed in this? No. Okay. What I'm actually going to do is exit FreeDOS. Oh. Image must be on a host or local drive. So did I delete the CD? Why is that not working? Image mount DOS fd12cd.iso tiso. Yeah, I mean, that works there, so I don't know what's up with DOS. And we're just going to head on over to util. There's a terminal program here which I'm going to sneak into my FreeDOS system. Oops. So we have a terminal program now which we can use to actually check that it's not just my code that's broken. Or if it is my code that's broken, that's somewhat helpful. So if I... Oh, it quit. Okay, that might explain a bit. Let's open up DOSBox again. What if I write testing? Okay, so there is some bidirectional communication happening here. And if I write hello in there, even though I type the key presses, it doesn't show up here. It just gets sent to it. So why isn't my program reading from COM3? Let's quit that. Does it need to read from it often? You know what, we're just gonna actually write the buffer back and then just try running the program. So let's write hello buff. And I'll just append that to it because DOS likes that. Okay, so in that brief moment of time, it seems to wait for input. So is there a way I can quickly just test? Testing, and I'll just hit enter. Why are you not doing this? I use lots of programs. For DOSBox or for DOS programming or just programming in general. Yeah, I tend to mostly write in C or assembly. For scripting I use Bash and Python, whatever's on Linux. A lot of the programming language is just easy to jump between. Once you know one programming language, you can generally figure out how to use ones that are like it. Like if you know Python, you'll be able to get the gist of Ruby. Yeah, C is pretty good if you want to do low-level stuff. I've just been enjoying assembly recently because it's very simple. Which is a bit weird to hear said, because it's simple in that there's only a few things that you can do, and there's a few places that data can be. So instead of having to learn all the syntax and how functions work, you just always know that there's just a stream of things that happen. So it opens the COM port and it doesn't read anything. Sweet. Thanks, I hate it. I'll just set that to 10, like it should be. Move BX AX. I don't actually need to push that. Are you a Windows programmer, Lonk? Because Windows can be a bit annoying to program with C. If you want to use external libraries that aren't just... Yeah, the semicolons are comments. This is just the particular assembly syntax that you'll use with flat assembler. Programming in Windows is a little bit difficult, at least for me, because in Unix, if I want to program something, I just use GCC. Like, I can write some terrible code here. And then write it, it'll complain about it, and then it runs. And if I want to include third-party programs, like I want to do math stuff, then I just add things like link math or link SDL2 if I have SDL2 installed. On Windows it's a little bit more tricky to configure out, although I used to program in Windows. It can just be a little bit discouraging and annoying because you don't have this ability to easily download software like you do in Linux. Usually you have to compile things. Why is this not reading? Let's look at DOSBox's source code. How do you know, oh sorry, don't call me late for dinner. How do you know which registers you can use at any moment? This is where the calling convention comes into play. In DOS, it's just generally with assembly. You have control over your registers, but then when you do something like hand your code off to another function, or you do an interrupt like this, you just kind of have to find documentation that tells you which registers are going to get used by the other program. So if I look up Linux's syscall list, you can see that here when I do syscall, I give it the syscall number, it gives me back racks, it gives me back the return value on that, and it will possibly use all these registers to read stuff in and clobber it. C has an interesting calling convention, and the C calling convention basically says that if you're calling a function, you have to what's the word? There's the callee and the caller, and when you call a function, you're responsible for saving registers, and then the function will clobber them. Here we go. If the callee wishes to use, I wrote DOSTR as an assembly 20 years ago, but I was never sure which registers I should and shouldn't be using at a given time. Yeah, it's convention. See, I'm not sure what DOS is actually going to clobber when I use it, so I probably should be pushing more stuff to the stack, but I'm not, because I don't have that much foresight. Lonk52 says, lists are so difficult for me. Yeah, they can be a complicated thing. Anything in particular about them that are difficult? Yeah, it's by convention, really. If you look here, I have the x86 calling conventions, and it's just... Wikipedia just is not a good source of information in this, but I have been just looking at the RISC-V and ARM calling convention, and they basically say something like, the caller is responsible for sending these registers to the stack because the function you jump to is going to use them, but it also says that the function you jump to has to save some registers because they belong to the caller. So there's kind of a division between the caller and the callee on who owns what and who has to save it. But again, that's the C calling convention. That's not assembly. Lonk52 says it's just how the numbers work. Like the first thing in the it messes up my code a lot. It's 0. You mean the iterator is 0? Or do you mean like the offset in the list? Do you mean like the 0-based indexing? 35. 3F, not 3F. Okay, here we were. So it's going to call read file 6510 assembly. I was looking at that the other day. Go away. Wikipedia. Oh, I swear, I'm using this in private browsing, so Google doesn't know, or is respecting that I don't want to be stalked that easily, so I'm not getting good results. Let's see. Oh, that's of the 6502. Yeah, the 6502. I was reading about that the other day. It is a simple chip. The only thing that really annoys me about it is it just has one it has, like, look at these registers. It doesn't have any. Like, what are you gonna do? And apparently that's because there's the 0 page, which is basically a block of memory that you can access easily. And you can put bytes in RAM, but still that's like loading from RAM. Long says how the first thing in the list is called as the number 0 and the second is 1 and so on. Yeah, that's confusing. It's done that way because convention, and convention is horrible. I wrote lots of Commodore 64 basic programs back in the 80s, but I could never find a good book at assembly at the time. Yeah, that's way before me. Same with for loops. Is this Python? Because I think there are for each loops too, but generally, yeah, starting from 0 is really weird, but there is kind of a reason for it. It's a reason that goes back to the olden times, and as soon as I find DOS read file, I'll quickly explain it. Maybe someone's explained it to you already, but I'll just... So, let me write a quick program to show you. So I have my hello world text here. Yeah, it's an offset for the list. So we have my string hello world here, and it's stored in this area of the program. So when I want to access the string, I have to start at 0 because that's the same as saying where the string is. It's the number of bytes plus the start of the actual thing. I'll actually show you right here. So let's see. Yeah, I should compile it with symbols, shouldn't I? I'm going to do this quickly. Yep, so this is called a fence post error. And this is, the fence post error is possibly the demon in programming, at least the one that affects me. If you're not good at maths, then you're just gonna get hit by this every single time you program. And you will learn to just die inside whenever it happens. So 1 to 10, that would be, it would start at 1 and then would use 1 as the offset. So 1 plus 1, and then you'd go up to 10. Or the code could be saying 10 is the last one and only going from here to here. Yeah, so my advice, if you want advice from random people on Twitch, is to just write it in Python and see what it gives you. And then remember that. yeah, I don't know why it would do that. That's really weird. I'm mind flooded by that. Why would it include everything except the last one? So why? So over here, if I actually So yeah, here's a quick example. That's my hello world string in memory, and this is where it starts. But if I do that's just going to be the first letter. So the first letter is the actual start of where the string is stored. What is the worst? Taking tests on paper is pretty bad. FCB read. That's not where I want to be. DOS read file. Okay, so it calls read. I'm not sure. I haven't gone through any formal programming education yet. I'm not sure if I plan to. I don't think I'd really do well in it. No, I don't have any formal programming education, it's just been messing around. Yeah. I mean, I do have an advantage in that I'm very interested in it, and I'm very patient. But generally there's a curve, and once you learn something, it just kind of helps you learn the rest. So it's really the first part that's hard, and I would go to a formal programming place for that if you can afford it. Serial read. Like, there's a lot of concepts that are just very hard to understand. What's a 3-level project? Is that... I haven't heard of that. Okay, my head is actually getting blown at this code. So, what should I do in order to figure out why it isn't reading that? The first option is reread the code. So we open com3. That works. We read the buffer. Three-level projects, more complicated projects, CP level 3 class, computer programming level 3 class. Yeah, I don't actually live in the city, so I think all the kind of computer programming classes I would do would be online based. which I suppose is just how programming tends to work these days when you're in a group with people. Pair programming is something that seems really good, but very hard to do if you don't physically have people around you. DX gets the buffer, AX calls the interrupt. So, I've hit an issue here. I don't know what I'm doing, so the solution is to find someone else who knows what they're doing and read their code. So let's find the FreeDOS terminal program and open it up and see what I'm doing wrong. Yep, in person is more interactive, and if you learn more that way, then good on you. Wow, that sounded sarcastic. I just try to be very positive about these things, because when I started programming, I had a big mindset where I was like, I have to program the right way. I have to use C and do things low level. And that was just not good. .404, great. Alright, the CD should contain the source code for this, I think. D12 CD. It's a lowercase ISO, so it cares about case sensitivity here. Why not? Let's copy the terminal to C drive. Let's go to C drive and let's unzip that. There's probably no reason not to unzip stuff into your C drive, except if you don't have unzip. Unzip terminal.zip, and it's going to give us the source code for that. And that looks complicated as heck. I need some more music. Let's see what else I actually have on my list. Let's play this. What license is this? Yeah, 60 by, that's good. It's a good excuse to get through my music list that I should listen to. Okay, let's see the source code for the terminal program and let's see what I have been doing wrong. This is why I love open source, because I can get schooled by reading code and there's no one to judge me on it, except the internet. Okay, term ANSYS, term com, term RQ. Let's look at term com. Yeah, expand the tabs, please. Working together with term RQ. Transmit, send data to the terminal port. This is using RQs. This is not what I want. Is it? Do I have to use RQs to talk to terminals? Maybe I'm just doing it wrong. Can I edit Oops. Can I edit COM3 and use the normal file stuff on it? Testing what's up. File. Oops. File saved. And does that write to it? No. Let's go back to... I have no clue what game I should make next. Tetris, that's a good one. Read from file or device. See also 27H, 40H, 90H. 27H, 93H. There's no 93H. 93H doesn't even make sense. That's... Oh, yes it does. Why did I think 93 is bigger than F? Okay, back to the interrupts. 93. I guess there's no such thing as 93H and the internet is a liar. Okay, DOS read from serial port. Does someone have an actual... There's this stuff in Pascal. Does that help? COM port, LCR. Let's visit Usenet, the true internet before the internet. Oh, that's NT. Echo can send strings to COM ports, but it ends each line with CRLF. Okay, so I'm writing the wrong thing. It should be COM port. Should I be putting type, comma? Should I be putting a colon after it? Is that what my problem is? I had to read-write the serial ports 25 years ago, but I can't remember how I did it. It was C or assembly. Well, that's... I don't know it either, sorry. I think at the moment the most confusing thing is that I'm just actually gonna quit DOSBox and have it constantly write stuff on my serial port. So we're gonna write yes, then hit DOSBox, and it's probably gonna cry a bit. Okay, it's crying a lot. So how am I going to write a whole bunch of garbage into DOSBox? It really doesn't want me to write yes into DOSBox. Is it trying to do a handshake? Oh, this is hell. So my current hypothesis is that when it's reading, there's no data in the buffer, and it just discards the data. Like it's polling or something like that, which is weird. So the way to test that would be using NC. Let's see. How do I type a whole bunch of yeses into my netcat program after waiting a bit? Is there a delay for yes? There isn't. Okay, so what we're going to do instead is write a loop in DOSBox. I'm not sure why I didn't do that before, but I'm going to do it now. So we're going to add loop, and how do you just jump to loops? Jump loop. I'm pretty sure this is going to ruin my DOSBox, but this is reserve word used as symbol. Loop 2. Illegal instruction. Jumps and calls. Do I have to move something into a register first? Let's look up labels. JCXZ branches to a label, does it? Do I need to specify that there's a label? What is that? Okay. I will not be put down by this strange assembly syntax. Jump at F. Entry. Local labels begin with a dot. Do I have to put a... do I have to do that? Okay, I was just weird. Okay, so it's printing the buffer now. Which is problem. This is problem because I'm just not going to see the stuff if it goes in. So let's make that a conditional jump. Okay, jump if AX isn't 0, I guess. So how do I compare stuff? It's compare, isn't it? So it would be compare AX 0, and we're going to jump if it's equal. Jump if equal compare AX. Is JE jump equal? JE, JZ is jump if equal or jump if 0. Let's just it's really strange to me that there's compare instructions here. I don't think RISC-V has comparing instructions. Maybe I just haven't used them enough. Compare, subtrahend, minuend, test. Oh my. Oh, I'm being a not smart person. Compare AX 0 if jump if equal. No. Time to get out the debugger. Let's reset the program. Okay. And it's gonna compare it. Flags, it compared AX at 0, 0. The 0 flag isn't set. Why does it say JZ? I wrote JE, didn't I? Yeah. I wrote JE. Oh, I am roughed. I am roughed. I don't know what that means, but I am that. Unless it means something bad. Can I only compare registers? It's a roundabout way. Why not use int14 over int21 for com? That's a good question. int14. Let's see if DOSBox provides int14. Here's your source code. Grep. int14 serial ports. int14 COM port. int14 handler. My assembly book suggests using int14 BIOS over int21 DOS. I don't have an assembly book, but that sounds like a great idea if it's going to work. So let's see. What does int14 want? Port D doesn't exist. So let's see. 0 to 3 serial port functions. DX is always port number. DX is port number? Oh. Okay. So how do we initialize the serial port? I think DOSBox might already do that. So let's just try and receive a character. Let's see. AH2DX0 uses hardware flow control. Params for initialization, and ALO would be do some quick maths on this. So bits 1 and 0. So bottom bits would be 11 because we're doing 8 bits. Stop bit. We're not going to do any parity bits. So that would be stop bit is bit 2. I guess I'll just have one of those. 5, 6, and 7. Let's do that. So is that 8 bits? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what do we actually, what is that? How do I have nothing on my computer that, oh no, I have Python. Oh, 99. 63. Okay, so let's head back to this hell that I've found myself in. Remove the loop because I don't know. I'll just, I'll copy that. You what, mate? Oh, that's right. I'm not in Unix. This is DOS. That doesn't make sense. Okay, so we should init com3. Why am I moving the low first? But that should be 63H, shouldn't it? I remember 63H. Out of memory, brought back some memories. Yeah, that seems like something that you wouldn't want to remember. (63H) to 14H 00. That should initialize. Oh, I have to have my. Though I think that might be dereferencing it. DX is the 0-based port number. Okay, let's pretend it's not dereferencing it. Why would you dereference something like that? That doesn't make any sense. We're in port 3, but it counts from 0. Let's remove this. Then we're going to read a character. Okay, so AL is the character we get back. So we're going to keep DX as 0H. Probably don't need to set it again, but I'm going to. DX AH02. I'll just set that to that. On return, AH is the port status. Okay, so this, I have to move this back to 3, otherwise I'm always going to keep moving to the wrong workspace. And let's try and read some stuff. No, my backspace. Okay, let's open this in Insight. F8, F8. What? Why am I? Okay. Reset. F8, F8, F8. DX shouldn't be that. Why is DX? I didn't set DX to that, did I? No. No. What's that? Dear God. Okay, so seems to be the actual way to do it. Let's just open up Insight and let us wonder what is happening here. So that initializes it. Any errors? AX returns 600. Let's check. AH is the port status, AL is the modem status. What is 6 in binary? 0, 1, 2, 3, 4, 5, 6, 2, 1. Overrun error, parity error. Yeah. Wait, is that AH? That's 60. Not 6. And that's hex. That's not 60, that's hex. So that's just 2 ones at the top. Timeout. Transmit shift register empty. That seems fine. Probably. That doesn't seem to be an error. That seems... I don't know what I'm talking about. Okay, so... let's load some... Oh! It can't init it if there's nothing to init. Go down to that 660 and F for the modem status. What is the modem status? F. So F is all of them. No, wait, it's not FF, it's just the first 3 of them. Cleared already. Changed. Okay, that makes sense. So let's put in a 1 and hit enter. And then we're going to jump down. Eight. Oh no, it was waiting there. Okay, let's try again. So as soon as it hits that, I'm going to have to hit enter. Oh no. 3, I'm going to hit enter. What did I get back? 80? Is that what I want? Debian at the moment. Though I might switch to Arch someday, I'm not sure. Port status. Bit 7 if call failed. My call failed. This is actually running on a server that has like 5 virtual machines going. So like all stream setups, it's pretty weird. Testing. So is that going to give me anything? 8? 80? Yeah, that seems like it's the top bit. So let's do... I didn't run. Oh, I'm not there. I am not getting anything in this serial port. And that should give me the status 63. What is 63? Two ones at the top. Data ready. Overrun error. That would make sense. This seems like a real timing error. But let's just keep going. So, int 14, 2, port 2, so we're going to write T there. It looks like we're going to have to do that loop again. If I can write it correctly this time. So compare alo jump equal loop. I'll just write LP1. AL. Compare 0 with AL. Invalid operation. Does AX work? Okay, that seems to be looping. So now let's hop over here. And that's always looping. Why you gotta be like that, computer? What if we write some data to DOS first? Maybe this is a caching error. Nope. This is trash. But we can search DOS int 14h example. Oh dear. It looks like int14h function OTH normally sets DTR signal only. This doesn't work with the nullmodem cable I am using for testing. Oof. Oof. And we're using a nullmodem cable here with DOSBox. If you bypass the BIOS routines and talk to the ports directly as an uplink, and in fact most COM programs do, then you can use signals whichever way you want, and in fact implement proper hardware handshaking. But Sergey is correct in that when DOS is trying to send something to another PC using BIOS routines over a null modem cable, then it will wait for the CTS that never comes and time out with an error depending on the port configuration. Ooh. Oh, I'm dead inside. Okay. How can we check this out and see if this is the actual problem? I guess we'll have to use an actual serial cable. Where do I have one? You're probably thinking, hey, it's a bit weird that you have a serial cable laying around. But it's a bit weird that you're asking too. What type? Are they just usual USB to UART ones? I have one laying around because somehow I spend a lot of my time developing stuff. No? So you've just got typical, 9-pin serial cables laying around? It's a bit janky, isn't it? What are you going to use those for? Oh, is that just an old thing? That's like, when you get old, you just grow serial cables. They breed like ISP modem disks. Every time you get a new modem because you're changing ISPs because it's early 2000s, they send you a new CD to go with it. It's fantastic. You just have 100 Big Pond CD discs laying around. But 30 years. That is older than me. Okay, what do I have? Oh, I actually do have a serial port on my laptop, but I don't have one of the cables. So I'm just gonna have to use this normal person serial port. Okay, time to remember which way ground goes in. Actually, I'm not gonna be an idiot and put ground in the wrong way. So I'm just gonna look up UART. And it's loading too slow. So I'm just going to put it in. There we go, that's connected. So I'm going to quickly just check to see if that works in my root terminal. And what am I going to do? Is it? No, that's the wrong port. Is it port 2? No. How do you quit screen? Alright. Woof. So I have a port connected on my computer to another computer, and can I send data through it? Oh shit. Did I knock the Ethernet out? Am I still streaming? Oh. I don't know what's real anymore. Oh, so Google's just dead. That's, yeah. That is something weird. So on my server, I currently have the serial cable hooked up, and on my computer that isn't a server that it's connected to, it looks like it's just not going to work. Why? Why do you got to be like that, computer? Actually, I know. I'll connect it to my main serial port, which has a TTI on it. And I know that works, I think. No, do I have it around the wrong way? Have I hooked ground in the wrong way? Is this my problem? Is the specific problem that I said I would look up on Google to try and figure out, is this the issue that I'm hitting? I hope not. I don't want it to be like that. It is not. Oh, this is hell. I feel like I'm missing something extremely obvious. So I am going to put it back into the machine that I had it connected to and boot that instead. Okay, that kind of works. Okay, so let's get back to the stream. And open up my serial cable and see what's happening here. What is that? Is that the wrong board? Oh, this doesn't have an OS in it. I shall plug this SATA hard drive in and then use a screwdriver to boot it. What am I doing with my life? And where did that SD card go? Okay, screwdriver. Boot from SATA. Yes, please. No? You're just going to give me 2 question marks? Really? This might actually be hell. This is... Okay, where's the SD card that I'm supposed to be using for this? Is it here? Is it this one? It's gotten a little bit sidetracked. But it's come full circle because I thought those things were important at the start, and it turns out they are. Have I got it flipped around? There we go. Okay. So I have an actual serial port here with an actual computery thing happening. And what the hell do I have on this? Nix OS from 2016 for ARM. Okay, this is weird. Why do I have that laying around? Doesn't matter. So can I plug that into my main computer? Ground faces south. Plug it into this port. And echo stuff to it. Okay, let's just unplug that and try this one instead. Nope. Okay, so we're just going to be using this weird broken implementation of U-boot as a sanity check. Okay, whatever. And the music's gone, but the dream is not dead. Cancel, cancel, cancel. No! I'll just see if DOS can read that. Okay, DOSBox. Serial 1 is going to connect to direct serial real port dev TTY USB 0. Okay, DOSBox. Oh, it booted? Oh, there's a recovery mode. I getcha. Novena parent Ohio. I didn't choose that. It chose me. Okay, let's see what our program is going to do. Sanity.com. Yes. No, that used the wrong COM port. Okay, sorry DOSBox. And we're going to use COM1. That's the wrong button. Man, this stream is nearly ended, I tell you what. Okay. No, still not getting anything. Maybe I need to detach it from the screen. Okay, root. Yes, then we detach. Kill DOSBox. We should, in theory, have a serial port that is giving some, Ys. And DOSBox should, in theory, be listening to those Ys. DOS port dev TTY USB 0 could not be opened. That should be on serial 1 for the first thing, but let's just try that. Serial 1, serial 2. Ah, it opened. Oh, sweet. Is this going to be it? Is this going to be possibly... No. 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 Unless I'm using the wrong one. Let's try again. Oh, that's right. Let's try just opening the COM1 file. Oh my god, this is killing it. DOSBox is dying. Oh, sweet. Sweet Jesus. Oh God, why am I killing it? Alright, let's just screen in. And let's just cancel that. And hopefully that'll be faster. No. Set that to COM1. Why is it 21? Okay, so it's not looping, and hello buff set to 1 or something. Let's exit that. So, no, I get nothing. This is possibly hell. So an actual serial port is not even helping me here. I think this is going to wrap up the stream for tonight. I have to do a lot more research and experimentation to see what the heck is up with this. What have we concluded today? Unix's read sometimes skips input. Maybe there's a race condition there. DOSBox can't read serial input. Int 21 or int 14 don't help. This is sounding like a Stack Overflow post. Yeah, so this is putting a dent in the future of the DOS Twitch bot if we can't get the chat into DOSBox. That's a weird noise. I'll have to go experiment, but I think this is the end of the stream for today. Thanks for hanging around, anyone. Ciao.